Our last of the mini unit lesson for Integrated 1, Unit 1, Lesson 4, which is phrases into algebra. So this is going to be really helpful for your SAT because most of the time they're not just going to give you a very simple combined like terms. They're going to tell you a phrase and tell you some words, and you're going to have to put it into an expression. So a lot of times they'll be like, okay, the perimeter is the sum of x and 7 for one side, and the other side is 2 times the product of x subtracted from 7, whatever. So those phrases are going to be how we put applications into our algebra. So again, this is helpful for the PSAT and SAT. So again, you should have these notes so that you don't have to write them down, but anytime they have addition, they're going to use the words sum, total, plus, increase by, more than, subtraction, difference, minus, decrease by, less than, and subtracted from. Those I put stars next to because those are turnaround phrases. So those means you actually are switching the way that they write them. So most of these, like, they're going to say the sum of x and 7, x plus 7. The difference of y and 13, y minus 7. The product of 3 and y, 3 times y. So times product of twice, so 2 times, double, triple would be for multiplication. Division, quotient, separate, divided by, half would be just divided by 2, a third would be divided by 3. Parentheses phrases, so if we have something that says times the sum of, so 3 times the sum of x and 7 would be 3 parentheses x plus 7. Times the difference of or between would be like 5 times the difference of x and y, 5 times the difference of x and y. So the turnaround phrase is less than. So 7 less than x really means x minus 7. Or 5 subtracted from x is really meaning x minus 5. So those turnaround phrases mean we're actually flipping them around. So subtraction is the only ones that we're flipping around. Everything else, and it only means when we're doing less than and subtracted from. Wow, that was a terrible line right there. Subtracted from and less than is where we're flipping those guys around. Okay, so translate each expression into each expression or equation. Translate into product of a number and 3, so we'll just call the number x. So x times 3, 4. 3 times x doesn't matter since we're multiplying. The difference between a number and 10, so difference x minus 10 between a number and 10. Difference subtracted. The quotient of a number and negative 5, so a number quotient divided by negative 5. So quotient, big word, product, word, difference. 4 subtracted from a number. So again, subtracted from a number. So 4 doesn't go first. The number goes first. Turnaround phrases. 4 subtracted from, so negative 4 from x. Okay, a little bit harder. The sum of twice a number, so the sum of twice a number, 2 times a number, and 7. So 2 times a number and 7, the sum together. The product of a number and 10 increased by 1. So the product of a number let's look back at that. Product of a number and 10. Okay, so 10x. Product of a number and 10 increased by 1. Add 1. Okay, a little bit harder. 4 times a number divided by 8 is 3. So did we do the equal signs? Okay, is means equals. So back to the first thing, let's write that down. Equals is means the same thing. So is means an equal sign. Okay, the sum of twice a number. Sum of twice a number. So twice a number and 10. Add 10 is 36. So equals 36 is means equals. 4 times a number divided by 8. So we don't have to solve these, we're just writing an expression. 4 times a number divided by 8 is 3. This one's going to be tough. Okay, 1/2 a number. 1/2 of a number is 8 less than the number itself. Okay, so the number itself, 8 less than that. So that's one of those turnaround phrases, less than. So 8 goes, or the number itself goes first, less than minus 8. Okay, so 1/2 a number, 1/2 a number is equals 8 less the number itself, so x minus 8, because that's that turnaround phrase. 15 decreased by the quotient of a number and 3. So 15 decreased by minus the quotient of a number and 3 is 20. So again, I know these phrases fairly well. I would keep that little phrase page really close to you when you're doing your practice on this. Again, they're going to use these kind of phrases in the PSAT and the SAT and expect you now, well, we haven't gotten into this, but you maybe will know in the next unit, is we're going to solve this. We will get x by itself and find out what that number is. And it could be in terms of perimeter, it could be in terms of number of miles that you've gone in a cab, it could be whatever in terms of whatever situation it is. So x is usually a number, but it could be also situations as well. So inequalities, again, we're going into those phrases, but using inequalities. So less than is usually written like this. Little alligator, and less than is facing to the left. Less than or equal to, less than, but also equal to. So a little symbol underneath it means that it could be equal to that number. Greater than, the pointy arrow is pointing to the right. Greater than or equal to, so pointing arrow still pointing to the right, but also little line underneath it means it can equal that number. Okay, a number is less than -10. A number is greater than or equal to -4. Okay, let's look at this one. These are a little bit harder to think of which symbol to use for our inequalities. A speed limit of 55. So let's think about that. Speed limit of 55. Can you go over 55? No. Can't go over 55. I mean, you can, you just might get a ticket. So let's call this the speed limit, or S. It doesn't matter, we could use an X. Has to be less than 55. So we can go 54, we can go 53, we can go 30. We just cannot go 56, 57, 58. We could be equal to 55. That'd be fine. A number is no less than 10. So numbers no less than 10. So 11 would work, 12, 15 would work. So that means that has to be greater than 10. No less, I'm going to say also equal to. Maximum number of 25. So try this one on your own. See if you can get that guy maximum number of 25. Come back, pause the video. Here you go. Talk out loud like you're still around. No, no. And I miss you. So x is less than 25 on this one. I'm going to say not equal to because it can't be 25, a maximum number of 25. So since it says that we can't actually equal the number 25, we're going to just not have an equal to symbol. So I guess you could probably make the argument on 23 for that too. That is it for our expressions into keywords and phrases. So again, please utilize this piece of paper that helps you determine what kind of symbols we're using to get our expressions and our phrases into expressions. And then we will move into our next unit after our little mini quiz over this pre-unit. So please move on to your practice.